my name's Frank, and today we're going to talk about rational exponents. Now, I hope you've encountered exponents that have been integer exponents like x squared, x cubed, maybe even x to the 0, and maybe even x to a negative power like x to the negative 3. But let's talk about a rational exponent. First, let's talk about a rational number. A rational number is a fraction, basically. The numbers you've encountered, like that you count on your fingers, 1, 2, 3, 4, they're rational numbers. It's a fraction. 4 is 4 over 1. Or 4 could be 8 over 2. Or 4 could be 16 over 4. But it's a quotient of two numbers. So, a definition for rational numbers is you take two numbers m and n divided by each other. Now remember, n can't be 0 because 0 in the denominator, it's impossible. That's why it's called undefined. So m divided by n is a rational number, provided these two numbers are integers. So you might say, well, what's an integer? Good point. An integer is this set of numbers. Notice you got negative 3, negative 2, negative 1, 0, 1, 2, 3. And if I said, guess what's next? You would say 4. And these dots mean it goes backwards forever. And these dots means it goes forward forever. So basically, it's the numbers you can count on your fingers, 1, 2, 3, 4, etc., etc., etc. Keep going. It's the 0 and their negative counterparts. Now you might say, well, what's not an integer? Well, that's where your rational numbers could come in. Like 1/2 is not on that list. 1/2 is in between. Then you may have learned numbers like pi that are called irrational numbers, but we'll save that for a later time. So today we're going to take fractions that are clearly written as fractions, maybe 1/2 or whatever, and we're going to learn how to handle that. Okay? So today's lesson will be on rational numbers, rational exponents, and a rational exponent, again, is a fraction of two integers. Okay. Now, to be consistent with the m over n, I rewrote it in that form, m over n. Then there's two ways we can approach this. Way one is, what's that mean? Well, in your study of radicals, which I hope you've had by now, this is called the index. You put the denominator as your index of your base a, and then you raise it to the nth power when you get done. Or you put your denominator as the index of your radical again, just like we did the first time, and you put a, but you put the m inside. They will both get you the same answer. The one I used most of the time is the top one, because when I raise a number a to an m power, it's usually a big power, the number gets out of hand quick. And then I got to go back and take a root of that, which sometimes is too much. So anyway, I'm going to practice the top one. Now this looks like a very complicated formula for you. I know it does. It's not a variable, not no variable, and no variable. But once you see enough examples for it, it ought to come clear, I hope. So let's look at the first one. What's 16 raised to the 1/2 power? Now, when I first encountered this, if someone said to me, what's 2 cubed? I knew how to approach it once I was taught. It means 2 times 2 times 2. That's pretty easy. But how in the world do you multiply? What's this mean? 16 to the 1/2 power. How can you multiply 16 1/2 time? So I could see where a student, I know I was at one time, what's this about? So we have to figure out a way to do it And if we look at our approach here, we're going to use this approach. So now n would be your 2, and m will be your 1. So using this, we're going to put 2 in that little v, and we're going to put 16 here, and you can put the 1 here, or the 1 here. Now, you've encountered this symbol before, I hope. That means the square root of 16. But since it's the square root of 16, it's understood to be a square root, but it means the same as this. That's the square root of 16. So when you see that symbol, it's understood to be a 2 in there. So this is just the square root of 16. And what is the square root of 16? The principal square root of 16 is 4. Now you say, okay, so do I have to, what's 1 power? Well, really that 1 power is not going to be significant here because it's understood to be a 1. But later it will be. So 4 to the first is 4. So when you have 16 to the 1/2 power, that just means the square root of 16. That's it. Okay? Now let's go to the next example. 64 to the 1/3 power. Now in this case, your m is your 1 and your n is your 3. So if you look at the rule we had, in the v of the radical, you put 3, you put 64, and you raise it to the first. Now, I know this is hard for you, some people. What number do you multiply 3 times by itself to get 64? Well, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3. Let's see, 3 times 3 is 9, times 3 is 27. Not yet. But what's 4 times 4? So that's 16. And 16 times 4, you might have to scribble it out on your paper. 16 times 4. Hey, that's 64. So this is called the cube, the third root of 64, which is 4. And you raise it to the first power, which is 4. That's your answer. There it is, those 4s. Let's go to the third example. 81 to the 1/4. All right, what goes in the v? The denominator, 4. 81 to the third. Now you say, boy, and we raise it to the first. Boy, the numbers keep getting larger. Well, what's the 4th root? What number do you multiply 4 times to get 81? And these numbers are going to get big quick. 1 times 1 times 1 times 1 is, of course, 1. 2 times 2, so that's 4. 4 times 2, 8. 8 times 2, 16. Not yet. 3 times 3 is 9. 9 times 3 is 27. And now it's 27 times 3. You might have to write it out. But when you do, you multiply, you say, hey, that's 81. So the 4th root of 81 is 3. And that's to the first power, which is 3. So, we could keep going 1/5 power, 1/6, but I think you have the idea. 9 to the 1.5 power is the next one. Now, You say, I thought this was supposed to be rational exponent lesson. It is. A rational number can be rewritten as a terminating decimal, 1.5. A terminating decimal can be written as a fraction. So 1.5 can be written as what fraction? Think about it. 1.5. It's got to be an improper fraction. Do you agree it could be written as 3 over 2? I think you'll say, yeah, that's 1.5. So there's your rational number. So if you have a decimal that's terminating, ending, just write it as a fraction. Now, what goes in the V? The 2. Now, you have a choice. Do you want to put the 3 there? I really don't. Gosh, no calculator. 9 times 9 times 9. Wow. Or do you want to put the 3 here? Yeah. Why not make the number smaller and then do the multiplication? Now, what's that mean? That means the same as the square root of 9, so you don't even need to put that there. Remember, that 2 is understood to be square root. The square root of 9 is 3. And what's 3 cubed? 3 times 3 is 9, times 3 is 27. Okay? All right, the next one is a fraction. 9 over 25 to the 3 halves. The lesson is on rational exponents. Fraction just has to be the base in this case. So what do? We write our radical. In the V, we put the 2, and we put 9 over 25, and we raise it to the third power. Now, remember, a 2 means the same as a square root. So what's the square root of 9? What number do you multiply by itself to get 9? You would say 3. What's the square root of 25? Hopefully you would say 5. And then you raise that to the third power. Now, 3 times 3 is 9. Times another 3 is 27. 5 times 5 is 25. 25 is a quarter. 25 cents is a quarter. What's 25 times 5? That's 5 quarters. $1.25. Done. Okay, our next 3 examples may review you on negative exponents. Now, a negative exponent. In one of my previous lessons, I derived all the rules on exponents. Feel free to please look at that if you'd like to see the derivation, but we're just going to go from there. We derived in that lesson that when you take a negative exponent, you just take the reciprocal of the base. So the base is understood to be 1 over, or 25 over 1. So what you do is you just, instead of writing 25 over that imaginary 1, you bring the 25 down. You got to put something up top. It's 1. And then you raise it to the positive 1/2 power. So a negative exponent means you take the reciprocal of the base and then you change the power to a positive. Now what's that mean? In the V of the radical, you put the 2, which is the square root, 1 over 25, and you raise it to the first. Remember, that 2 means the same as a square root. The square root of 1 is 1. The square root of 25 is 5. And by now you may say, why even write the first exponent up there? But we can, or if you don't need that step, you can go from here down to there. Our next example is not only is the exponent negative, but the base is negative. So let's deal with the exponent. What do we do with a negative exponent? We take the reciprocal of the base. Well, the base is negative 64. So that's 1 over, or it's negative 64 over 1. So we flip it over, we get 1 over negative 64, and we raise it to the positive 1/3 power. Now what's that mean? In the radical sign, in the V shape, you put the 3rd root of 1 over negative 64. Now if you choose, you could put a negative 1 up top. But you can't put them both negative, because then a negative over negative would be a positive. So you put the 1, put the negative sign either up top or on the bottom. Now, what's the cube root of 1? You say, that's 1. But careful here. What's the cube root of negative 64? Now, you've got to be very careful on this one in 2 regards. Number one, you've got to make sure you can do it. If this had been a square root, you can't do it, because a number times itself has got to be positive. But if this is an odd number, 3, 5, 7, 9, you can take that root of a negative. Because here's what happens. If you take a negative times a negative, you get a positive. But then if you multiply the odd time, 3rd time, it becomes negative. So what's negative 4 times negative 4? Hopefully you say 16. What's 16 times negative 4? Hopefully you say negative 4. Now, a lot of times the person will write that answer as negative 1/4. That's your call. Student asks me which one is preferable. Usually we write the negatives up top, but it's not wrong. Okay, both of them are correct. Well, our last one, we have a negative base and a negative exponent, but this time we have a numerator that's not 1. So what's the rules? Okay, you take a negative exponent says you take the reciprocal of the base. Well, that means this goes downstairs, and this guy goes upstairs. And you raise it to the 2/3 power. I tell the students this negative exponent could be like an escalator. If you're up top, you go to the bottom. If you're at the bottom, you go up top. Okay, now what's this mean? You take your radical. In the V, you put the cube, 3. And you take 64 over negative 27. And when you finish that, you raise it to that power. Now again, I'll leave the negative in the bottom. If you would like, you could erase that negative and put it up there. Okay, what's the cube root of 64? I think we talked about that today. 4 times 4 times 4. What's the cube root of a negative 27? Remember, to take a radical root of a negative number, this has got to be odd, which it is. Okay, the cube root of a negative 27 is a negative 3. And then we square it. What's 4 times 4? 16. What's negative 3 times negative 3? 9. There it is. So this is our first lesson on rational exponents. I hope you have made it clear to you. I will be doing a follow-up one that's a little bit more complex, but first let's study this, let's understand this. All right. Hope I did well, hope you understand it. See you next time.